Okay, so good afternoon to all. In our previous lecture, we discusses about the fundamental concepts of thin film and thick film. Okay, we also discusses the thickness of other film and as compared to other film, what is the dimension or what is the size or what is the thickness of thin film, which is we already discusses in our previous lecture. Fine. So we also consider or cover the some of the example, that is the acrylic gold brass or other thick film, or as compared to other foils or gold aluminum foil. We also covered this example. Okay, and what is the thickness of thin film, which is we already covered inside that previous lecture, and what is the size of atoms and molecule, which is near about in terms of angstrom or less than that. Okay, that is the size of atoms and molecules. But if we consider about the thin film, the size of the thin film is around 10 nanometer to several micrometer. That is the size of, or that is the thickness of thin film. Okay, and we also discussed about the cohesion and adhesion. So cohesion means what? The tendency of two or more type of molecules. Okay, the tendency of two or more different kinds of molecule to bond with each other. That is nothing but a adhesion. Okay, so we have taken some of the example, that is we have considered one example, that is H2O molecule. This is the H2O molecule. Okay, and this is the copper molecule. Okay, that type of example is nothing but adhesion. And in terms of cohesion, it means the similar kind of molecules or similar types of molecules are attracted. Okay, or we can say that the molecules are bond with each other, same kind of molecules. Okay, so here we also discusses, this is our substrate. Okay, A is nothing but your substrate. Okay, and B is what? B is what? B is your deposited material. Okay, so look at here. This is our substrate. A is nothing but a substrate. Okay, and B is nothing but a whatever we have deposited some kind of molecules onto that substrate. So there is some thick layer was happened. That is nothing but a thin film. Okay, and that deposited layer is nothing but a thin layer, or that is nothing but a thin film. Okay, so that material is, we can say that that material is nothing but a copper oxide material. We can say that zinc oxide material we have deposited onto the substrate, or we can say that tin oxide material we have deposited onto the substrate. So B is your thin film. Okay, and A is your substrate. Okay, so look at here. If we consider this is the this is the substrate, that case that pencil is indicates a substrate, and if we bombarded in by using the some of the technique, that is synthesis technique, and if we bombarded or if we deposited some of the material onto that substrate, so that layer or that thick layer, or we can say that that thin layer is nothing but a thin film. Okay, so there are technique, sputtering technique, chemical vapor deposition technique, or physical vapor deposition technique, vacuum technique. So there are different types of technique to deposit a material onto that substrate. Okay, we are not deposited a thin film. We are deposited a material onto a substrate. आपण मटेरियल काय करतोय त्या सबस्ट्रेट वरती डिपॉझिट करतोय. आपण थिन फिल्म वर डिपॉझिट करत नाही. वी हॅव डिपॉझिटेड सम काइंड ऑफ मटेरियल ऑनटू ए सबस्ट्रेट, नॉट ए थिन फिल्म. Okay, so that this is your substrate. A is your substrate and B is your deposited material. Okay, B is your deposited material. Look at here. Okay, this is your film. Okay, and simultaneously these are the atoms, or we can say these are the molecules, or these are the ions which is deposited onto the substrate. Okay, which is we have already discussed in our previous lecture. Fine. Now let us start the next point or next concept. That is what? The thin film, the definition of thin film. Okay, so fundamentally in your exam or in your university level exam, if they are asking they define the definition, define the term with thin film, or what is the definition of thin film, or or what is mean by thin film. So you have to write a definition, that is a thin film is a layer of material. Okay, material is nothing but a different kinds of atom or molecules or ions. Okay, or material is nothing but a what? Zinc oxide material, for example tin oxide material, titanium oxide material, or any kind of material, that is nothing but a material. So what is the definition? A thin film is a layer of material ranging from fraction of nanometer to several micrometer in thickness. Okay, in thickness. Getting my point? So fraction of nanometer, in bracket there is written one word, monolayer. Okay, mono means single layer. Mono means there is deposited only one layer, and having a thickness is around some fraction of nanometer to several micrometers in thickness. That is nothing but a thin film. Getting my point? So that is the unique and that is the definition of thin film. Okay, so why thin film is important? Why thin film is very much important in the area of nanomaterial, nanotechnology, or research or material science? Because there are several types of applications, there are several types of advantages was produced by using the thin film. Like such as electronic semiconductor devices are the main application benefiting from thin film construction. Okay, construction means if we prepare a thin film by using some of the techniques, so that film we can use in the area of semiconductor devices. Okay, so that's why here the first sentence indicates the semiconducting material in thin film form are a particular interest because it has a various number of applications. Okay, so semiconducting material have a very small band gap. Having a very small band gap or a tiny band gap, we can say that what is the band gap of silicon? What is the band gap of germanium? Germanium having a band gap is around 0.71 electron volt. Okay, and silicon having a 1.1 electron volt. That is the band gap. Okay, band gap is nothing but a band distance between the two band zone, that is the conduction band and valence band. Okay, and in we can consider a semiconductor material having very small band gap is there. Okay, and if there is very small or tiny band gap, so conducting behavior shows very properly, it shows little bit good conducting behavior. And if that material did not show the conducting behavior, so we have to deposit some kind of semiconducting material. Okay, that's why the semiconducting material in thin film form are of particular interest because it has various number of applications such as transparent electrodes, photovoltaic devices, solar front panel display, surface acoustic wave devices, low emissivity coating for architectural glass, various gas sensors, and heat reflectors for advanced gauging in solar cells. Okay, so these are the applications which is very much famous in the area of thin films. Okay, by constructing the thin films, we can fabricate a thin film and we can produce a application in that particular areas. Getting my point? And these are the application we can cover. These are the application in our fourth module. Okay, we will discuss that application in our fourth module. Okay, so I am only focuses on a basic nature of thin film. here. Okay, so what is the definition of thin film? We already discussed it. And why thin film is important? What are the advantages of thin film? Why thin film construction are important? Okay, so due to that reason, due to that application purposes, we have prepared a thin film. Okay, whenever you have chosen the project, okay, that time you have also seen some of the example. You are going to study during your project time. Okay, so why thin film? Due to the surface and interface effect, because we are only coated or we are only deposited any kind of material onto that surface only. Okay, we are deposited some kind of material onto that substrate surface only. We are only deposited onto that substrate only. Okay, getting my point? If we consider this is your substrate, and if we deposited some kind of material by using some of the technique, physical vapor deposition technique, chemical vapor deposition technique, laser appellation technique, okay, Lagmuir bludgeon technique, okay, these are the technique, these are the route to deposit some kind of material onto that substrate or onto that substrate surface. Okay, okay, so this is we will discuss it that point in our last chapter. Okay, the controlled synthesis of materials as a thin film is a fundamental step in many applications. Okay, so what is the how much thick are there? What is the thickness of that particular layer? Okay, depends on the thickness of that layer, the application was produced. Getting my point? Monolayer or multi-layer thin film we can produce, we can develop, no problem. If we deposit it onto the substrate as a carbon atom, okay, if we deposit it onto that surface of carbon atom, and if that material was dried, okay, if that material was dry, again we can deposit it in another atom also. We can deposit another atom or another molecule or another material also. Okay, if suppose this is one layer, okay, if suppose this is one layer, and if we again if we deposit another material, that is multi-layer or double layer. If we deposit one more layer, that is multi-layer. Okay, monolayer, double layer or multi-layer. Multi means more than two, more than two. Okay, it is possible, it is possible to deposit a number of material onto that particular thin film. Okay, so this is all about the thin film or basic information of thin film. Now, as per the topic or as per the topic, we will discuss about the first point in our chapter, that is the vacuum technology. Okay, so vacuum technology is very much important phenomena or important tool during the coating of what, during the coating of material onto that particular surface. Okay, there is required some kind of vacuum. Okay, so let us discuss a vacuum technology. Vacuum coating processes are characterized by a number of advantages. Okay, vacuum coating processes, I will show you some kind of very important examples by by showing some of the videos. I will show you some of the videos. Okay, vacuum coating processes are characterized by a number of advantages. This includes variability of the coating materials, reproducibility of the film properties, and adjustment of the film properties by changing the coating parameters and the grade purity of the coatings. Getting my points? So vacuum technology is very much important because to remove a unwanted air from that particular chamber, look, listen carefully. Okay, if inside the atmosphere there are various type of gaseous molecules are present, there are numerous atoms or there are numerous molecules are present inside the atmosphere, such as hydrogen, nitrogen, oxygen, argon, helium. Okay, some kind of gaseous molecules or this kind of molecules are present inside the atmosphere. Okay, so due to that reason, if we need to deposit a carbon atom onto that surface, so it is difficult. It is difficult because simultaneously the gaseous molecules which is present inside the atmosphere, that gaseous molecules are also simultaneously deposited. Okay, so difficult it is difficult to deposit a pure carbon atom onto that surface. Okay, and if we want to deposit a very much pure carbon atom onto that surface, so during that technique or during that reason, we have to remove that molecules, which molecules, which is already present inside the atmosphere, that molecule. Okay, that molecule if we remove, so due to that reason, there is required to produce a vacuum. Okay, so inside the earth, it can't possible to create a vacuum. Okay, above the ozone layer or above inside the universe, there is available some kind of vacuum, but inside the or in our surrounding area, there is no vacuum, there is different kind of gaseous molecules or there is some kind of air is available. Okay, so that there is required some kind of evacuated chamber. Okay, we need some kind of evacuated chamber, and that chamber is completely evacuated by some of the glasses or some of the technique, some of the metallic materials. Okay, so there is some technique or there is some method. Okay, and there is vacuum technology, there is some vacuum technology was attached there. Okay, I will show you. Okay, I will show you in your next slide. Look it here. Okay, there is methods I will explain. But if we remove the, if there is some evacuated chamber, and if that that particular chamber, inside that particular chamber, there is some gaseous molecules are present. Okay, and by using the vacuum pump, okay, there is, if we consider this is the evacuated chamber, and there is connected a vacuum pump. Okay, there is a void or there is a pipe of that particular vacuum chamber, and there is vacuum machine. Okay, that is nothing but a rotary pump, turbo pump. By using the rotary pump and turbo pump, we can remove the unwanted air, unwanted gases, unwanted air. We can say unwanted air because inside the air there are various kind of molecules are present. Okay, to remove from that chamber, to remove or to suck or to vanish that air, so there is required a turbo pump or rotary pump. Okay, and if we remove all the air from that particular chamber, if we remove that particular evacuated chamber, all kind of air if we remove, so there is only available, what is available, there is only vacuum is available. Okay, in Marathi word निर्वात पोकळी. Okay, vacuum is nothing but a निर्वात पोकळी. Okay, means vacuum, inside the vacuum there is no air is available, there is no other gas is available, there is no other material is available. No means no. Okay, and there is only vacuum is available. Okay, and after that, by using the electrode or by using the other technique, we can evaporate a material, and if we keep inside that chamber, if we keep the substrate inside that particular chamber, and if we heat some of the filament, okay, or if we spray some of the material onto that substrate, so only pure layer was formed, pure layer of that particular material, such as carbon, copper. Getting my point? Okay, so that is the importance of vacuum technology or vacuum coating. Okay, which we will discuss it in our next slide. Okay, so look it here in this slide carefully. So these are the technique, these are the methods to deposit a material onto that particular substrate. Okay, which methods are available to deposit a different kinds of layer onto that particular substrate? That is physical method. Physical method means PVD, physical vapor deposition. These are the physical method. Okay. Another one is the vacuum evaporation. Okay, listen properly. Look it onto that particular slide. Vacuum evaporation technique or vacuum evaporation method. That is one of the method. Electron beam evaporation method. Sputtering method. Okay, these are the physical method. Okay, and we will discuss this method in our next module. Okay, and these are the chemical method like plasma assisted chemical vapor deposition method. Plasma assisted CVD means chemical vapor deposition. Lagmuir bludgeon method, that is nothing but a LB method. These are one of the method to deposit a material onto that particular substrate. Substrate means any kind of substrate. Okay, you can consider a glass substrate, you can consider a plastic substrate, you can consider a metal substrate, any kind of substrate. As per your choice, you can take. Okay, as per your interest, as per your choice, you can consider any kind of substrate. Okay, another one is the plating method, that is electroplating method, electroless plating method. Okay, these are the route, these are the method, these are the technique to deposit a what material onto that particular substrate. Okay, just a minute. These are the technique to deposit a material onto the particular substrate. Okay, getting my point. Now let us discuss about the vacuum technology. Okay, so vacuum is nothing but a, we can say that vacuum is a device or vacuum deposition technique is nothing but a solid material are heated up to high temperature to vaporize them. Thus this vapor are condensed onto a surface from a thin solid film. Okay, the vacuum evaporation is essential because these are the conditions, these are the properties. Okay, so vacuum, I already explained, vacuum is nothing but a nirvas प्रक्रिया. Vacuum is nothing but a there is no other air was present. Vacuum is the empty space. Empty space means we can say that there is no other air was present. There is no other air was present inside that particular chamber. Okay, so why vacuum deposition techniques are important? Why vacuum deposition techniques are important? Okay, and how we can measure the vacuum? How we can measure the vacuum? These are the important key points. These are the important questions. Okay, vacuum by we can measure a vacuum in terms of what? In terms of what? What is the unit to measure a vacuum? What is the unit to measure a vacuum? That is millibar or bar. Bar is the unit or millibar is the unit to measure a vacuum. Okay, how much vacuum is available inside that chamber. Okay, if the particular amount of vacuum is available inside the chamber, then we can start a experiment, we can start a that particular system and if we start that particular system, then deposition process was started like continuously. Okay, that if we spray that particular molecule onto the surface, or if we evaporate some of the material, if we heat some of the material, then that material is available in the form of vapors. Okay, that if we heat the particular material, then the material was boiled and the vapors was formed. Due to that reason, solid material are heated up to high temperature. Solid material like which one? Aluminum, copper, gold, silver, this kind of solid material. Okay, so solid materials are heated up to high temperature to vaporize them. Thus, these vapors are condensed onto a surface from a thin solid film. Okay, so we will show you. I will show you some of the system. Okay, there is condensation will happen. Okay, if we heat the solid material, then at high temperature, at the same time, vapor was evaporated. Okay, vapors was formed, and if we cool that vapors, okay, by using the cooler or by using the cooling chamber, by using the cooling pipeline is there. Okay, at that time that vapor was deposited onto that surface. Okay, for example, look at here, this is your solid material. Okay, and if we heat from that bottom, if we at high temperature, okay, and that molecule or that material was vaporized. Okay, and simultaneously that vapors was spread in everywhere. Okay, and if there is chiller or chilling pipeline was present, and due to that reason that vapor was condensed, okay, onto that surface. Okay, and simultaneously that molecule was deposited. Okay, so the vacuum evaporation is essential. The vacuum evaporation is essential because the material will heat at lower temperature in vacuum. Why vacuum evaporation is essential? Why vacuum technology or vacuum technique is important? Because the material will heat at lower temperature in vacuum. If we heat at a very lower temperature, so it is possible to evaporate that material. Okay, the material will heat at lower temperature in vacuum. It is possible. That's why vacuum evaporation is essential. The effect of oxide can be minimized from on boiling on the surface. Third one is the number of impurities in the deposited material can be minimized large enough. Okay, it is possible to minimize some kind of impurities if we simultaneously if we deposit a copper as well as aluminum. So how much number of copper is deposited and how much number of aluminum is deposited, that calculation or that we can minimize. Okay, that ratio we can minimize. Okay, that term we can minimize. That's why this third sentence indicates the number of impurities in the deposited material can be minimized large enough. Okay, largely possible. Getting my point? Number four is it is possible to make between source and the substrate. Substrate is your choice material and source is whatever you have to deposit it. Okay, source means your material. It is possible to mask between source and substrate and obtain a sharp pattern on the substrate. Sharp pattern, whatever you have to deposit. Okay, sharp pattern means uniform layer was obtained. Uniform layer was formed. Getting my point? And the main advantage of the vacuum is that the adhesion of the film increases due to increase in the due to increase in and better film can be formed. Okay, adhesion means the tendency of the two or different two or more molecules to bond with each other. Okay, so adhesion is possible. Maximum number of adhesion is possible. That is mean free path. The molecules was deposited everywhere in the uniform layer, in the uniform way. The main advantage of the vacuum is that the adhesion of the film increase due to increase in and better film can be formed. However, the grain size of the atoms also increases and the film form will again be a better film. Getting my point? When the vacuum is there, then less number of atoms or ions are present and the successive time of the two collision increases. Due to this, there will be less number of collision and the atom and will have more energy, resulting loss of energy will be less. Finally, the atom and ion will strike at the substrate with more kinetic energy so that the adhesion will better, so the adhesion can maximize. Okay, so these are the essential. Vacuum evaporation is essential due to that reason. Due to that five important reason, the vacuum evaporation is essential. Getting my point? So I hope that you might be understand the concept of vacuum evaporation, why vacuum evaporation is essential.